Number 30, determine the smallest integer that makes this inequality true. So what I'm going to do is solve like a normal equation, combine like terms, subtract 7, I get negative 8x is less than 8. Divide both sides by negative 8. But remember, since you're dividing by a negative, you have to flip this around. So you get x is greater than negative 1. Now, this is not your answer per se, because you have to determine the smallest integer. So think about what this means. They're saying they want all numbers greater than negative 1. Okay, think about a number line. You have negative 2, negative 1, 0, 1, 2, 3. Okay, so right now we're on negative 1. We want all numbers that are greater than negative 1. What's the first integer greater than negative 1? It's 0. The smallest integer that works is 0. For number 31, all these points are telling the residuals for a set of a scatter plot. So anytime there's a pattern in your residual graph, a pattern indicates that the relationship in the original data set is not linear, and therefore it's not a good line of best fit. Graph A. A landscaper is creating a rectangular flower bed such that the width is half the length. If my length is L, then the width is 1/2 of L. To find the area, remember we're doing length times width. The length is L, and our width is 1/2 L. We know that the area is 34 square feet. So what I'm going to do is then say L times 1/2 is basically, I'm going to call it 0.5 L squared. Now this is a quadratic equation, but you could solve it a little differently. I am going to divide both sides by 1/2. In this case, you should get 68 equals L squared. Square root. Square root of 68 to the nearest tenth is 8.2. But please notice it says that right in solving an equation to determine the width. We just found the length, so in order to find the width, we know that it is 1/2 of the length. So, therefore, the width is 4.1. Now for number 33, they want you to tell if these two systems have the same solution. So what I'm going to do is start off with the second system. I wrote the top equation over here and the bottom one on the right. Now notice how the right one only has one variable, so I could solve this normally. So what I'm going to do with this y equals 6 is I'm going to plug it into here. 8x plus 9 times 6 equals 48. 8x plus 54 equals 48. Subtract 54, you get 8x equals negative 6. Divide by 8, you get x equals negative 0.75, and y equals 6. So there's my solution for the second system. Now we want to see if it's the same for the first. To solve the first system, what I'm going to do is multiply the top by 12 and the bottom by negative 8 in order to get everything to get the x values to cancel out. So when I multiply everything by 12, I get 96x plus 108y equals 576. When I multiply the bottom by negative 8, I get the following. So when I add from top to bottom, those cancel. It's the additive inverse property. 108 plus negative 40y is going to be 68y. 576 minus 168 gives me 408. Divide both sides by 68, I get 6. Okay, so we have half of the same thing. So now I need to see if x equals negative 0.75. So I'll plug this back into one of my original equations. Okay, and if you notice, this is the exact same thing as we did over here. Okay, so we're going to get x equals negative 0.75. Now you have to justify your answer. This was your work. Okay, so you need to state whether you agree with Albert. I agree with Albert.